Alright, so today we're going to review for your test. You have a test tomorrow, so your test is going to be on integers and integer operations, LCM, GCF, adding, subtracting, multiplying, and dividing fractions, and that first section that we did from the book, which was solving two-step equations. This would just be a review, so it's optional. You don't need to take notes unless you want to. But you won't be graded for these notes like a regular lesson. I do suggest that you try to do these problems on your own before you listen to me, and that way you really know if you're prepared for this test or not. So let's get going. So first thing you're going to be tested on is integer operations. So here we have a subtraction problem. -8 minus 5. So remember, when we are doing these type of problems, we want to change the subtraction to addition, and then change the second number to its opposite, which would be -5. And then this is just a simple addition problem. So remember, when we're adding integers that have the same sign, we add their absolute values, and then we put back their common signs. So we add, then put back their common sign. So in this case, we'd have 8 plus 5, which is 13, and then we put back their common sign, which would be -13. Over here we have -6 plus 4, so we are adding integers with different signs. When we're adding integers with different signs, we subtract their absolute values. So it would be 6 minus 4, which is 2. And then we add the sign of the bigger absolute value. So the bigger absolute value was -6, which gave us 6. And that integer originally had a negative sign. So it would be -2. So with product and quotient, you just need to remember that anytime you are multiplying or dividing by integers with the same sign, your answer is going to be positive. Anytime you're multiplying or dividing by integers that have different signs, your answer is going to be negative. So here we have -12 times 7. That's a negative times a positive, so that means our answer is going to be negative. And 12 times 7 is 84. Over here we have -15 times -6. That's a negative times a negative, so our answer is going to be positive. 15 times 6 is 90. So same when we are dividing. Here we're dividing a positive 42 by a -7, so positive, negative, different signs, which means our answer is going to be negative. And 42 divided by 7 is 6, so it would be -6. And over here we're dividing a negative by a negative. Again, same sign, answer is going to be positive. And then 72 divided by 9 would be 8. So here we're finding the greatest common factor of 36 and 45. So when you find problems like this on your test, I want you to do it the exact same way that we did in class with prime factorization, factor trees. If not, you're not going to get credit for the problem. So here we have 36, and you have to complete a factor tree to find the greatest common factor. So we break 36 up. We could break that into 2, 3 times 12. And then 3 is already a prime, but 12 we could go ahead and break up into 3 times 4, and 4 would just simply be 2 times 2. And then we do the same with 45. You have to use factor trees when you are doing this on your test. So this would be 5 times 9. 5 is already prime, but 9 can be broken up into 3 times 3. Then just remember, you need to circle all of the common prime factors and multiply them. So the greatest common factor of 36 and 45 would simply be 9. So least common multiple, there are multiple ways of doing it, but one way would just be to create that chart and find multiples. Okay, I'll keep it with red. 40, 30. So 40 times 1 is 40. 40 times 2 is 80, and I know I can't multiply 30 by something to get 80, so we'll keep on going. 40 times 3 is 120, and that right there is where I think I should stop, because if we do some factors of 30, we have 30 times 1 is 30, 30 times 2 is 60, 30 times 3 is 90, and then 30 times 4 is 120. So that would be the least common multiple. Least common multiple of 40 and 30 would be 120. So when you have these type of problems, just create that chart. Or if you want to do it with the factor trees, you can do it that way too, but I'd recommend that you just do it with this multiple chart, and you'd figure out your least common multiple will be 120. All right, so here we have 5 and 7/12 plus -3 1/4. So there are various ways that you can go ahead and solve this, but I would just change them both to mixed numbers right off the bat. So 5 times 12 would be 60, and 60 plus 7 is 67. That way you could practice changing these impropers. And then that would be plus 13, negative, 13 over 4. And when you're adding fractions, you need to remember that our denominators must be the same. So we need to find the least common denominator, or the least common multiple of 4 and 12, which would, in this case, would be 12. So we would need to change the 4 to 12. Luckily, we'd be able to leave 67 over 12 alone, because that already has a 12. And how would we do that? By multiplying by 3. So if we multiply both the top and the bottom by 3, we end up with -39 over 12. And once you have that same denominator, you just add the numerators. And we are adding integers that have different signs, so that means we are going to be subtracting. And that would be 28, and it would be positive 28 over 12. And once you get your answer, you don't need to change it to a mixed number, but you do need to simplify. So the greatest common factor of 28 and 12 would be 4. So we'd have to divide both of these by 4, and that would leave us with our answer, which is 7 over 3. And you could just leave it as an improper. So here we have 2 5/8 times -5/9. So remember, when you're multiplying fractions, you have to change any mixed number that you might have into an improper fraction, or a fraction greater than 1. So that's what we do first, which would be 21 over 8. And we're multiplying that times -5/9. And I haven't been saying this, but I hope you've been doing it. Go ahead and, as we're doing these problems, pause the video and try to do them on your own before I start explaining it. And that would really give you a clue as to whether you understand it or not, or whether you should try to come to tutoring before the test. So once you've changed the mixed number to an improper multiplying fractions, you just multiply the numerator with the numerator, and you multiply the denominator with a denominator. So 21 times -5 would be -105. And then 8 times 9 would be 72. And I want to go ahead and show you something with this, because you can simplify this. So I want to show you something with this. Give me one moment. Okay, so we know some shortcuts to factoring and to simplifying already. For example, you all know that if two numbers are even, like 80 over 68, it might not be the greatest common factor, but we know if two numbers are even, we could always divide it by 2. That's a rule that you know. Okay, or if two numbers end in either a 5 or a 0, we know that we'd always be able to divide it by 5. So that's another truth that we know. It's a given. So there's another one that you all might know, but if you don't know this, then it might be useful. But if the sum of the digits of a number is divisible by 3, then the entire number is divisible by 3. So what do I mean by that? Well, here we have 105. All the digits of 105 are 1, 0, and 5. So if we add 1 plus 0 plus 5, we'd get 6. And 6 is divisible by 3. So that would mean that 105, in this case negative 105, is divisible by 3. Now this would only work if 72 is also divisible by 3. Well, if we do the same shortcut, 7 plus 2 is 9, and we know that 9 is divisible by 3. So therefore, both negative 105 and 72 are divisible by 3. We can divide both of these numbers by 3. And if we do that, we would get our simplified form of this, and in this case 3 actually is the greatest common factor. We get our simplified form of the fraction, which would be negative 35 over 24. So here we have 2 divided by negative 2 3/10. So keep change flip, but before we do that, we're going to want to change our mixed number to an improper. We would end up with 2 over 1 divided by negative 23/10. So now we would need to keep change flip. That's how we divide fractions. We multiply by the reciprocal. So that would be 2 over 1 times negative 10 over 23. Then we just simply multiply straight across, and we get our answer, which is negative 20 over 23. That can't be simplified. So we have 2 equations here. We'll start with 3. We'll start with 3 plus b over 2 equals 8. So remember, when we're solving equations, we perform the order of operations in reverse. So remember, our goal when we're solving an equation is to isolate the variable. And how do we do that? Using inverse operations and our properties of equality. So the first thing we're going to want to get rid of is this positive 3. Using inverse operations, that would be subtracting by 3. You have to do the same thing on both sides. Whatever you do on one side, you do on the other side. And that would leave you with b over 2 equals 5. Now this is b over 2. Just remember, this right here means division. So it's b divided by 2. Inverse operations, the opposite of division, is going to be multiplication. So how do we get rid of that 2? We would multiply both sides by 2. Your 2's would cancel, and you'd be left with your answer, which is b equals 10. Especially on this test, you'd want to plug 10 in for b, substitute 10 for b, and make sure this works. 10 divided by 2 is 5, and 5 plus 3 is 8, so it does work. So make sure you check your answer, especially on a test. You want to make sure it's right. So here again, we would get rid of the minus 5 first. And how do we do that? The opposite of minus, or the opposite of a negative, would be a positive. So we'd add 5, and that would cancel these out right here. But whatever we do on one side, we do on the other side. That's your laws of equality, properties of equality. N over 3 is going to be equal to negative 3. Now, again, that fraction bar there means division, so we'd have to multiply by 3 on both sides. And if we do that, we end up with our answer. This cancels out. We end up with our answer, which is n equals negative 9. And again, especially on your test, you're going to want to plug that in and make sure it works. And in this case, negative 9 divided by 3 would be negative 3, and negative 3 minus 5 is in fact negative 8. All right, again, remember, I challenge you to pause these and try to figure them out on your own before we work them out together. Now, this problem, I want you to pay close attention to, because this problem might have a very similar one to your to this on your test. So with these word problems, remember, you want to circle or underline key pieces of information. So it says Deshaun had some candy to give to his 5 children. He first took, and I'll go ahead and circle this in blue, 2 pieces. Oh, I probably should have done that in green. For himself, and then evenly divided the rest among his children. Each child received 4 pieces. With how many pieces did he start? So we want to define our variable first, which is p, and p would be the amount of pieces he started with. So we know he started with a certain amount of pieces, P. Now what's happening with these pieces? He's giving these pieces to his 5 children, but before he gives these pieces to his 5 children, he takes two pieces. And we're going to look more into these keywords next chapter, but take, when you think of take, what are you thinking of? Addition, subtraction? Hopefully you realize that it's going to be subtraction. He first takes 2 pieces, okay, before he hands them out to any of his children. And then he divides them evenly among the rest of his children. So that one's pretty simple. We know we're going to be dividing the leftover pieces by his children, and he has 5 children. And that is going to equal how many pieces. It's not going to equal the total amount of pieces. It's going to equal how many pieces each child receives, which is 4. That is your equation. Now you're going to need to solve it. So remember, you want to do the order of operations in reverse. So before you even mess with the parentheses, you're going to go ahead and want to take away that division. It's divided by 5. So the inverse would be multiplying by 5. If you do that, the 5's are going to cancel out. You have to do the same thing on both sides, and you're left with P minus 2 equals 20. Okay, now that's just simple. You just have to add 2 on both sides. Opposite, inverse, add 2 on both sides, and you're left with what P equals, which I erased it, but if you remember, we defined P as the total amount of pieces that he started with, which gives, this is our answer then, because that's what we were looking for. We were looking for how many pieces he originally started off with, and that is 22. So here's one that's pretty similar to the last one we did. Pause it, try to do it on your own. So this is pretty much exactly the same as our last problem, just with different numbers. So I hope you really did pause it, and if you haven't, do that now, and I hope you solved it on your own. So again, if we read this, it's Sanji had some candy to give to his 4 children. He first took, remember took is going to mean subtraction, 5 pieces for himself, and then evenly divided the rest among his children. Each child received 5 pieces. So after he took the 5 pieces and after he divided it amongst his children, each child has 5 pieces. With how many pieces did he start? So again, you're going to have to define the variable, which again is P, and you don't have to use P, but I'll use P, and that P stands for pieces he started with. And again, let's read this problem. He first, before he divided it amongst his children, he first took the total amount of candy he had, and he took 5 pieces. Then he divided the leftover, which would have been the amount of pieces minus the 5 he took, amongst his 4 children. And that is going to equal the amount of pieces that each child received, which is 5. That's not the total amount. 5 is not the total amount of candy he started off with. It's the amount of pieces each child received, and that's given to us right over here. Now, we just solved this equation the same way we solved that last word problem. First, we're going to want to get rid of the 4. How do we do that? By multiplying by 4. 4's are going to cancel. And we're going to be left with P minus 5 equals 20. And then we add 5 on both sides. Whatever you do on one side, you have to do on the other. And that leaves us with our answer, P equals 25. So how many pieces did he start off with? 25.